Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Pink Booklet, Practice Test 3, specifically Unit 7, Question 21. Now, ACER's being a bit sneaky here. You might look at this question and think, oh, it's a physics question about Ohm's law. They're giving you voltage, resistance, and it's talking about current. However, there is an ulterior motive here by ACER. They're masquerading this physics question pretty much as a way to see how well you know how to convert between ratios and how to read ratios. So if we take a look at the stimulus, it's telling us that in general, the risk to a person who makes contact with an electrical source is directly proportional to the size of the current. So we know that obviously if we take a look at Ohm's law, we know that current equals voltage divided by resistance. So what we have to do in question 21, it says that which of the following is the closest estimate of the ratio of the risk to a person from a 240 volt source compared to a 110 volt source? So they're giving us the table of the voltages and the resistance. So let's just calculate the currents first. I mean, in this instance, we don't need to use our units. I know I'd be very pedantic about units, but we can omit the units here because the answer doesn't express in units, so that's fine. But for practice, I would leave the units just in case. So we've got here 110 volts, 210 volts. So I'd probably just convert it to an easy to work number. So let's just do 100 divided by resistance, which is 3000. So that's going to be 1 on 30. So let's take a look at the 240 volts. So I'll just convert it to 240 volts, 2400 ohms resistance. So we'll do 240 over 2400. I mean, you can do any estimation approximation, but it does say in question 21 the estimate, so you can play around the numbers here. It's just easy to work this way. So if we cross this off, 224 over 240 is 1 over 10, so that's going to be 1 over 10. So now we've achieved these fractions. So the voltage for the 110 is going to be 130, and the current is going to be 1 over 30 for the voltage that's 110, and the current for the 240 voltage is going to be 1/10. Now, this is where the trick comes. It's easier to work. So if you've got 1 over 30 and we have our 1 over 10, we want to figure out the ratios here. It's easier to work in ratios if they're going to be in the same fraction. So if we've got a 1 over 30 here, let's convert this to over 30 as well. So if we times this side by 3, this side by 3, we're going to end up with 3 over 30. So you can see clearly now, you're going to have 4 parts. You're going to have a 1 over 30 and a 3 over 30, which means, now this is where the trick comes as well for students. It's not going to mean that it's going to be 2 to 1, because some students might see this and say, well, it's going to be the 3 parts, so there's 3 parts more, so it's going to be a 2 to 1, but that's not true. What we have here is 4 parts. So keep in mind, we've got 4 parts here. So therefore, we have a 3 to 1, and that means it's going to be a 75% to 25%. So it's important to know these conversions and these ratios, because in this practice test specifically, ACER asked a few questions where you had to work through converting ratios. So it's easier to look at it this way. So it's a 3 to 1. So the only option there, well, is 4 parts. The only option there with 4 parts has to be C. So again, with these sorts of questions, working with ratios doesn't have to be difficult. Just conceptualize here what we're doing. We've got for the 240 volt, the current is going to be 3 over 30. For the 110 volt, the current is going to be 1 over 30. Clearly, you're going to have a 3 to 1, so there's 4 parts. It's going to be 75% to 25%. Therefore, your answer is going to be C. So if you have any more questions about this unit, you can post them in the comment section below, or you can contact us directly. We'd love to help. Thanks for your time. Bye now.